Okay, so now in this recorded lecture, I'm just going to a little bit talk about the types of sampling. So you know, we have already discussed different problems related to the single sampling. What is a single sampling plan? This is a plan in which the decision to accept or reject a lot is based on inspection result of a single. So mean what an inspector do? He or she just take one sample from a specific lot, and then after the analysis, after conducting the OC curve, after sketching the OC curve, after calculating producer risk, consumer risk, and on the basis of that they decide. So I mean this is only related to the single sampling plan. If the number of defective is equal to or less than the acceptance number set by the plan, then the lot is accepted. If the number of defective is more than the rejection number, then the lot is rejected. So I mean this is very simple scenario. The data required for sampling are, so the lot size we need in order to conduct an analysis for the single sampling plan, we need only the lot size, the sample size, and the acceptance number and the rejection number. So we will be able to easily calculate to conduct that plan. But now what we will do when we want to conduct a double sampling plan. So first of all, you need to know what is a double sampling. The double sampling plan is a plan in which the decision to accept or reject a lot is based on inspection result of at the most 2 samples. So we would not be able to decide on the basis of only a single sample. Basically, in most of the experiment, the inspector, let's suppose he already maintain a threshold that if in a specific lot, if the defective are more than 2, then we will reject the lot. But let's suppose if an inspector wants that if there are 2 defective item in the first sample, then what he will do, he will take another sample from the lot. Then on the basis of that, when she combine the result of those analysis for the 2 sample, then on the basis of they will decide that either they will accept the plan or they will reject. So the data required for the double sampling plan are the lot size, as we already need this in the single first sample size, because how many unit she will take in the first sampling and how many unit or number she will take in the second attempt, the second sample size, and the rejected number and the acceptance number. So we need these things. A sample size is drawn from the entire lot and inspected for a given characteristic. If no clear decision can be reached, another sample is taken and 2 samples are combined for their size and defective in them. Then based on the combined information, a decision as to the acceptance or rejection of the lot is taken. So basically we will not be able to decide based on the first sample, but actually we will be able to decide on the basis of the 2 sample. We will combine their results, we will combine the analysis, we will combine the defective number, we will combine the acceptance probability, and then on the basis of that we will decide. So now this is a very simple example. In this example I am just going to calculate, to use the probability approach in order to calculate that how you will calculate the probability of acceptance or the probability of rejection while using the double sampling. So I mean in this example we will take 2 samples. A double sampling plan, so please read this question. A double sampling plan calls for taking a first sample of 60 and accept the lot if it contains no defective. So what they do, they from a big lot, they will take a 60 unit which will be considered as the sample size, and they will accept the lot if there is no defective. So I mean if all the 60 are accepted, if all 60 are effective, there is no defective, then we will accept it and reject the lot if it contains more than 3 defective. So in this case they will accept at the first instant if there are no defective. Then they also a little bit relax the threshold. There is also a chance that we will accept the lot of this sample size 60 if it contains more than 30 defective. So I mean if the number of defective are more than 3, they will reject it. So if the number of defective in the first sample is 1, 2 or 3, then it's okay. But if it is greater than 3, then in that case they will reject the sample. So for this purpose, in order to further clarify, in order to further clean the decision, a second sample of 60 is taken. So now they are taking another sample of 60 from the lot, because at the first sample they already took 60, in the second sample they took another 60, and the lot accepted if the combined number of defective in both the sample does not exceed. So now this is a condition now that in both sample, now our sample size first one and second, the lot will be accepted if the number of defective does not exceed 3. So mean if it is 1, if they found 2 defective, if they found 3 defective, so still we will accept in both samples. But if the combined number of defective, let's suppose they took one defective in the first, let's suppose 3 in the second, we will reject it. But if they choose one defective in the first, 2 in the second sample, so still we will accept the lot. But if the number exceeds than 3, we will reject that sample. We will not be able to accept that whole lot. So now in this case, we want to use a probabilistic approach. What is the probability that a lot containing 5% defective will be accepted by the above plan? So what is the probability now? A lot containing 5% defective. Now in the lot we have 5% defective. For example, if we have 100 units, so in those 100 units, the 5% of that 100 unit will be 95 will be effective, while 5% will be defective. So now in order to solve this question, I am just going to solve this in order to calculate this probability of acceptance, the probability of rejection, and then overall we will decide what should we need to do. What will be the probability to accept this lot, and what will be the probability to reject this lot, because it contains 2 samples. So now we will calculate. So I'm just going to start from probability of acceptance based on the first sample. So as you people know that N1 is 60, and probability, because they already mentioned that a lot containing 5% defective, so the defective probability is 5%, so we can also write this 0.05. okay, so what will be the NP? We want to calculate the mean which is also called lambda for the Poisson distribution. So 60 into 0.05, which will be equal to 3. okay, so at this way, now we want to calculate. Let's suppose that the lot will be accepted, there are 0 defect. So in this case, how we will calculate? Let's suppose we will write this lambda. So lambda x e minus lambda and x factorial. So this is basically the Poisson formulation. The lambda value we already calculate this 3 0, because at 0 they already mentioned that the lot is will be accepted if it contains no defective. So we first want to calculate when there is no defective, e minus 3 and divided by 0 factorial, because x in this case is 0. We want that there are no defective. So when you simplify it, it will be 0.0498. okay, so this is the probability that the lot will be, there will be no defective item. Probability of rejection. Now we want to calculate probability of rejection. Now we want to calculate probability of rejection on the basis of first sample with more than 3 defective. So they already mentioned, and reject the lot if it contains more than 3 defective. So now it will be rejected if it contains more than 3 defective. So it will be accepted on if there are only 1 defective, if there are only 2 defective, or there are only 3 defective. So mathematically we will write this. So basically we want to calculate probability of rejected. This R represents rejected. So what will be the probability of rejected? 1 minus the accepted probability. So what is the accepted probability? We can write this summation x is equal to 0, and this will be 3, because when it exceeds than 3, so we will reject this x e minus 3 divided by x factorial. So when you put the values in this, let me 1 minus, so the first one will be 3 is 0, e minus 3, okay, e minus 3 0 factorial plus 3 1, e minus 3 1 factorial plus 3 2, e minus 3 2 factorial plus 3 3, e minus 3 and 3 factorial. So when you simplify it, probability of rejection will be 1 minus 0.0498 plus 0.1494 plus 0.2240 plus 0.2240. So when you simplify it, you will get 0.3528. okay. So now we want to calculate, we already calculate probability of rejected, 1 minus accepted. So basically these units are accepted, because lot will be accepted if there are 1 defective, 2 defective or 3 defective. But when you exceed more than 3 defective, then your lot will be rejected. So now we want to calculate probability of decision on the basis of first sample. So probability of acceptance plus probability of rejection. This will be our results. This will be the decision basically. This decision on the first sample. So when you put this value, we have already calculated this probability, which is 0.0498. 0.0498 plus 0.3528. So which is equal to 0.4026. So probability of inspection of the second sample. So probability of inspection of the second sample. So this will be the probability that you will be going now for the second sample. Okay, so we already conduct this process. 1 minus probability of decision from the first sample. So it is 1 minus, which we already calculated, 0.4026. So now there is 0.5974% is the probability that you will be going for the second sample. So basically we calculate this probability of inspection of second sample. Now there is a chance 0.59% that we will be going to the second sample. So when you calculate, because they already mentioned that what is the probability that a containing 5% defective will be accepted by the above plan. So now we are coming to the second sample now. Probability of acceptance on the basis of second sample. Now we will calculate the chances. So probability, what will be the chances? That one defective in the first sample, because the lot will be rejected if it contain more than 3 defective. So now it will be a combination. Let's suppose in the first sample, which we have already conducted, now we are in the second sample. Let's suppose there are only 1 defective in the first sample. So how many defectives should be in the second? There is a chance that there will be no defective. There is a chance that there will be only 1 defective, and there is a chance that there will be 2 defective. So 1 plus 0, 1 plus 1, 2, 1 plus 3. So all these are basically chances. Now we will add all these chances. Plus R, there is also a chance, there is also a combination that maybe there will be 2 defective in the first sample. So you can see these are 2 defective in the first sample. Or there will be 0 or 1 defective in the second sample. So 2 plus 0, 2, 2 plus 1. So we not going to exceed more than 3 because the lot will be rejected. Or maybe all the 3 defective found in the first sample and there is no defective in the second sample. Or so this is the only 1 chance. Okay, but in the other 2 there are 2 to 3 chances. Maybe there will be 2 defective in the first, or 0 defective in the second, or there will be 1 defective in the second, or maybe there is 1 defective in the first, or maybe there is no 0 defective in the second, or maybe there is only 1 defective in the second, or there will be 2 defective. So now we want to calculate. So 1 defective in the first sample. So how we will calculate 1 defective in the first sample? Because we will multiply these chances now. Okay, and we will add all these 0. So what we will do, x is equal to 0 to 2. So 0, 1, 2. Now it will be 0. So we will put 0 e power minus 3 0 factorial plus summation means sum of all these. So when it is 1, 3 power 1 e power minus 3 1 factorial plus 3 power 2 e power minus 3 and 2 factorial. So when we add all these, so I have already calculated these things. This is for the 0, this is for the 1, this is for the 2. When we add this, we will multiply this with the 1 defective in first sample. So when we calculate 1 defective in the first sample, which we have already calculated 1 defective in the first sample, which is this one, 3 power 1 e power minus 3 and 1 factorial. When you calculate this, it will be equal to 0.1494. So this is why 0.1494. You will multiply plus, now this is the probabilities of this option. 2 defective in first sample. So we have already calculated 2 defective. So we have already calculated 3 power 2 e power minus 3 and 2 factorial. And for this, we have already calculated 0.2240. So 0.2240 multiply by, for this, because there are 2 options now, 0 or 1. So we will use the R rule of probability. Okay. So 0 to 1. So 3 power 0 e power minus 3 0 factorial plus 3 power 1 into e power minus 3 divided by 1 factorial. So we have already, this is for the 0 and this is for the x is equal to 1. And similarly, we have already calculated this 0.049 and multiply with this one. And this is the 3 defective in first sample. So when we simplify it, we will calculate 0.119. So basically, this is the probability of acceptance on the basis of second sample. We have calculated, and we have already calculated probability of acceptance on the first sample. Now the overall probability of acceptance, so probability of acceptance is equal to probability of acceptance of first sample, which we already calculated, probability of acceptance on the first sample on the basis of first sample, which is 0.4026, okay, and probability of acceptance on the second sample, okay. So basically we have already calculated this, which is 0.0498. Acceptance means there is no rejection, okay. So this is acceptance on the first sample, 0.0498. Then the acceptance of the second, so this is 0.119. So this is the probability of acceptance, okay. So this is basically the LPOP value 0.167. So at this way you will calculate the probabilistic approach in order to calculate the probability of acceptance of a sample. So I hope that you understand. Thank you.